A rumored Tesla chip factory just turned into a $119 billion question. It started with drone footage, land speculation, and a county tax vote tied to a massive industrial site. Then the numbers escalated fast. First $20 to $25 billion, then $55 billion, and now a possible $119 billion build-out. If real, this could affect artificial intelligence chips, electric cars, humanoid robots, and even space infrastructure. But the project is being widely misdescribed because the biggest secret may be who is actually leading it. TeraFab is not just a bigger Tesla factory. The concept being discussed is a vertically integrated semiconductor megafab, meaning one ecosystem that could handle chip design, wafer fabrication, memory integration, advanced packaging, and testing without depending on a long chain of outside suppliers. That matters because modern artificial intelligence chips are not just printed and shipped. They need specialized architectures, high bandwidth memory, complex packaging, thermal management, validation, and enormous cleanroom capacity. A true TeraFab would try to bring those steps under one coordinated industrial roof. The key correction is that the full-scale Grimes County project is not best understood as a Tesla-only plan. Based on the structure being reported, SpaceX appears to be the lead player, with Tesla and Intel involved as strategic partners. Tesla's Aga, Texas activity looks more like a prototype or pilot line effort, a smaller proving ground for processes, tools, and early designs. The intended customers would still include Tesla. Full self-driving needs inference chips. Optimus would need efficient onboard compute. Musk's artificial intelligence ambitions would need massive accelerator supply. But the clearest driver may be SpaceX. Radiation-tolerant processors, aerospace-grade systems, Starlink infrastructure, launch operations, and eventually orbital manufacturing needs. So TeraFab is less a car company side project and more a Musk network semiconductor supply chain. The next question is obvious. Why attempt something this difficult instead of buying from NVIDIA, Samsung, or Taiwan? Semiconductor manufacturing company. Because the companies Musk is building all run into the same wall, compute is no longer just something you buy when you need it. It is becoming the scarce raw material behind autonomy, robotics, rockets, satellites, and artificial intelligence. Though Tesla needs custom silicon for full self-driving, not only in vehicles, but in the training systems that improve the software. Optimus would need efficient chips that can process vision, balance, motion, and decision-making inside a moving robot. SpaceX needs hardened processors for spacecraft, Starlink satellites, ground systems, and future communications infrastructure. Artificial intelligence needs huge accelerator clusters for model training and inference. The problem is that the best chip makers already have a line around the block. Taiwan Semiconductor Manufacturing Company serves Apple, NVIDIA, Advanced Micro Devices, Qualcomm, and dozens of other giants. Samsung has its own capacity pressures. Advanced packaging, high bandwidth memory, and leading-edge wafers are all limited, and the companies with the biggest orders often get the strongest priority. That creates a geopolitical risk as well. Much of the world's most advanced chip production is concentrated in Taiwan, directly inside one of the most sensitive military flashpoints on Earth. A blockade, earthquake, export restriction, or foundry backlog could delay products that depend on steady chip flow. For Musk, that is the strategic reason to even consider a TeraFab. It would not be about saving a few dollars per chip. It would be about controlling the timeline of the hardware stack. And once that logic clicks, the rumored scale starts to make sense. The factory is not being sized for one product cycle. It is being imagined for a future where every car, robot, satellite, and artificial intelligence system needs specialized silicon at industrial scale. The reported footprint is what makes TeraFab feel less like a factory and more like a new industrial city. Filings and reports point to a facility of roughly 100 million square feet at the former Gibbons Creek power plant site in Grimes County, Texas. For scale, Giga Texas, the giant Tesla vehicle factory outside Austin, is often described at around 10 million square feet of floor space. TeraFab would be in the range of 10 Giga Texases, dedicated not to assembling cars, but to making the silicon brains behind them. That comparison matters because chip making is not just open warehouse space. A semiconductor fab needs clean rooms, vibration control, chemical handling, water treatment, power systems, gas systems, advanced tooling, and layers of support infrastructure around the actual production lines. When the footprint reaches this size, the building itself becomes only one part of the machine. The compute target attached to the project is just as extreme, more than 1 terawatt of artificial intelligence compute capacity per year. Musk has claimed that current global artificial intelligence chip output is nowhere near what his companies could eventually need, and this is the kind of number that shows why. Some claims circulating around TeraFab go even further, including larger acreage estimates and lifetime chip production figures. Those should be treated more cautiously. The facility footprint and investment filings are the firmer pieces of the puzzle. And that leads to the next question. If the ambition is this enormous, how much money is actually committed on paper? The money trail is where the TeraFab story gets much more precise. The public headline is the biggest number, a possible $119 billion build-out over a long horizon. That is the figure that makes the project sound like one of the largest private industrial bets in American history. But it is not the same thing as a check already written or a legal promise to spend the full amount. The investment path appears to have moved in stages. Early public discussion centered around roughly $20 billion. Later filings pointed to an initial phase closer to $55 billion. The $119 billion figure represents the potential full build-out if the project expands all the way. The binding commitment reported in the agreement is much smaller, and it is tied to SpaceX. SpaceX is reportedly committed to invest at least $5 billion by 2030 and to create 1,800 jobs by 2035. That is still a major project, but it is not the full $119 billion upfront. Grimes County approved the tax incentive package in a 4-to-1 vote. The structure includes a 100% property tax abatement paired with payments in lieu of taxes, so the county still receives negotiated payments while offering a major incentive to land the project. The most important detail is flexibility. The agreement reportedly includes walkaway provisions and limited penalties. That means the project can be slowed, resized, or abandoned if chip technology shifts, capital markets tighten, political support changes, or the business case weakens. So the real story is not that $119 billion is guaranteed. The real story is that Tesla and SpaceX appear to have secured room to attempt something enormous, while legally committing to a much smaller first step. The reason this plan is even technically plausible is Intel. Intel's role is reported as confirmed, not just rumored. The company is expected to help design, fabricate, and package chips at scale, using the kind of advanced foundry capabilities that Tesla and SpaceX would not realistically build from zero on their own. The key phrase is Intel 14A. In plain English, that means Intel's next-generation manufacturing process, aimed at the sub-2 nanometer class of chip making. It is part of the race to produce smaller, faster, more power-efficient chips for artificial intelligence, autonomous systems, aerospace hardware, and high-performance computing. That matters because TeraFab would not simply be a Musk-controlled factory trying to reinvent semiconductors in Texas. It would be a massive customer-backed industrial project connected to one of the few American companies still trying to compete at the leading edge of chip manufacturing. For Intel, the upside is just as important. Intel Foundry needs major outside customers to prove it can manufacture advanced chips for companies beyond Intel itself. A TeraFab commitment could become a flagship example that Intel's foundry strategy is real. Even then, this is not full vertical integration. Advanced chip making still depends on extreme ultraviolet lithography machines from suppliers like ASML. Those machines are some of the most complex tools ever built, and they show why the semiconductor supply chain cannot be replaced by one company, one campus, or one billionaire. The full-scale TeraFab is not expected to rise beside Giga-Texas in Austin. The reported site is in Grimes County, around the former Gibbons Creek coal plant area, a very different setting with a very different set of problems. That location matters. A leading-edge fab is not just a building filled with clean rooms. It needs enormous and reliable electricity, industrial water access, upgraded roads, emergency response capacity, wastewater handling, and security. At this scale, the project could require dedicated utility systems because a normal rural infrastructure base was never designed for one of the most advanced semiconductor campuses on Earth. The former coal plant site gives the plan a logic. It already has an industrial history, power connections, and land that can be assembled for heavy development. But converting that footprint into a semiconductor megaproject is not a paperwork exercise. It means turning a local landscape into a strategic manufacturing zone. That is where the local pushback becomes important. Residents raised concerns about transparency, water, tax incentives, and whether county leaders were moving too quickly. One commissioner voted no on the abatement package, and some locals said openly that they felt the county was being sold out for a promise they could not fully verify. This tension is the real bridge from announcement to execution. Winning a tax abatement can make a project look inevitable on paper. Building it means satisfying utilities, regulators, contractors, suppliers, local governments, and residents, while trying to deliver one of the most complex factories ever proposed in the United States. The hardest part of TeraFab is not pouring concrete. It is making chips that actually work at scale, with yields high enough to justify the cost. Advanced semiconductor manufacturing is built on absurd precision. A single wafer can pass through hundreds of process steps, with lithography, deposition, etching, cleaning, inspection, and testing all tuned to microscopic tolerances. One tiny contamination issue, one unstable chemical process, or one misaligned tool can turn expensive wafers into scrap. That is why the biggest chip makers in the world still struggle at the leading edge. Taiwan semiconductor manufacturing companies Samsung and Intel have spent decades building process knowledge, supplier networks, and engineering teams, yet each has faced delays, cost overruns, and yield problems on advanced nodes. This is not an industry where money alone buys instant mastery. A Tesla-backed TeraFab would also need extreme ultraviolet lithography machines, specialty gases, ultra-pure water systems, vibration-controlled floors, clean room automation, and thousands of experienced workers who are already in short supply. Recruiting them to a new Texas campus would be a project inside the project. So the realistic timeline is not a quick fix for vehicle chips or Optimus brains. It is a 15-year strategic bet. First comes site preparation and permitting, then equipment installation, then process qualification, then yield learning. Only after that does high-volume production become credible. If it works, the prize is enormous. Tesla would not just own another factory, it would own part of the hardware foundation for its cars, robots, data centers, and artificial intelligence systems. But getting there means entering the most unforgiving manufacturing race on Earth. So the real TeraFab secret is not a hidden Tesla factory. It is a SpaceX-led, legally cautious, strategically massive bet on controlling artificial intelligence hardware. The $119 billion vision matters, but the smaller commitment shows how megaprojects really begin. Thanks for watching. Comment below. Genius vertical integration or the riskiest chip bet of the decade?